Assalamualaikum. I am Mariam Ali, and today I am going to explain about the QUARTUS software and about the basic introduction of the Verilog code used in this software. So let's get into it. First of all, this is the basically the main thing here is a Cyclone 1, which is a chip uh, bashed on this development board. This development board is named as FGPA, that is the field programmable gate array. So basically these is also for here, this is the old version, but the latest we can see the Cyclone 5 have basically 300,000 above logic elements, and it is used for the heavy circuits or heavy uh, operators, we can say that application things. And this Cyclone 2 contains 8,000 across logical elements, but it is also at a low cost, like the other one, and can work for the basic logic operations like we have to study today. So this FPGA contains thousands of clock logic blocks and communication lines, and to this we perform different things here. So let's get into it. So for this we have to download a simple, I downloaded the QUARTUS file, QUARTUS 15 or QUARTUS 13, but I run the QUARTUS 13. Just run this one and the setup of this simulation, and we'll get this software here. Just download it properly. So for properly, let's how to create a new project. Name it like I name it STIA. Next, no, as have new trick project, so I contain it empty project. Next, so here this is I'm using the Cyclone 5, which I told about before. Here the name filter that you have provided, you have to name them, or even for now I don't want it, so I don't name any filter or device etc. So here's the format, we have to make the Verilog code, so I click the Verilog HTML, next, and finish this. This is how I created our project. Now for creating a file here, I just simply put this by clicking this, or by clicking this file here we can select a new project. There are thousands of files or things we can select or use, but for now I have to do the Verilog coding today, so I click the Verilog HTML file to form my Verilog code. Verilog codes are actually very simple. So let's get into the very basic thing. This one. Let's copy them and paste here. So this, first of all, a module and the end module. This the start and the last thing. What are the inputs you are giving to a logic gate? What are the output you are giving to the logic gates? And the sign thing is that the logic gate condition, or we can say the operation, what are you going to perform, as here it is the I gave it C is equal to A and B, like that. So for the module, well, as I gave SDIA, so I have to provide this name SDIA, like that, and it takes time, so I don't going to pick it now. I'm just going to run the thing I have done today, or I have to start compilation. So I have to yes and just save it where you want file or any folder you want, save it and use it. So now I'm going to use my file here by clicking on the desktop. I have to get into the file here, as this is the gate file I'm using now, so it is the file here. Other are not using now, so I just run it. It's gonna take time here. It actually takes a lot of time. So I'm not going to use it now. So just showing you here for the RTL viewer or to form a gears schematic circuit, we can say that. So this is like that RTL viewer. This is here. These are the actually IEC sign of the all gears. As this is a symbol, traditional symbol that we are studying before. What is the IEC symbol of this? Like this is this for the AND gate, for the OR gate, for the NAND, for the XOR, for the NOR, and for the XNOR, like that. So this is the first logic gears. All basic logic gears, one code like that. So here I define the module logic gears A, B. A, B are the input here, and all other things we are using like AND or NOT, NAND, NOR, XOR and XNOR I defined here. So by further I define these operations here and like that. So for this, for getting the circuit of this, I define it here, this form. It's gonna take a lot of time here, so this is why you can add RLT where we can go that. So this is how this form here, these AB and that thing. But further we have other thing. De Morgan's law we have to prove, for example, as we studied in our previous lab 3 video. So I defined here about the De Morgan's law and these Boolean functions. I just implement here to check more about this software sign and just doing that. Let's get into there. RTL viewer. RTL viewer for just De Morgan's law. This one. Like I combine it like F function, F1, F2, doing the same functions like we've studied before. So this is the main thing. Basic waveform of the software. To get the basic waveform of the software, we have to simply open our, let's get into this thing first. Opening it. For example, I'm setting this graph. Taking a lot of time. I am not going to show here file cause it takes long time. Okay, so this is here by selecting this, just here, go here, select this, okay, and insert bus, or you want to here's a list, as these are the list of the sum I here. So just if you want to select one by one, just do it like click on this and go to here. But if you want all input and output, just do that. This second one, click OK. These we insert the node, or you can say it's bus. Okay, these are the where is shown these lines and the crisscross. So the crisscross is the input, is the output which we run here by runtime simulation, and other are the inputs like A. For the A I have to provide it 10. For the B I have to provide at 20. As you know that A is the 0 1, it is just like the binary table, like 0 1 0 1, it is 0 1 0 1 0 1 defined here. And next BB 0 0 1 1 0 0 1 1 0 0 1 1. So this is how this works. And for the next one, it is the double of it, 40. Last we select 20, so we select the 40. Oh, oops, sorry. This is 20, and this is 40, like that. Okay, so this is how the waveform forms. It is the 0, it is 0 0, and it is 0 0 0 0, like that. How we form in our binary tables things. So this is how this thing form AB 0 0 whole, and at end it get the whole here 0 1 at high for 1 high like that. For the Morgan's law as proof here properly, like 0 1 0 1 0 1, and as for the proof of law we can see that the left side and the right side has the left input and the right are equal, so its waveform equal just like here, so it's proving the law here. And these are the Boolean functions and for these functions here. So these are the Verilog coding. We have for the Verilog coding we just have to define the main thing is module, input, output, assign and end module. For the module we have to define the operation name or the thing we have, or you can say the file name, and further we have to put the thing and then input what we are providing to a circuit like there A and B, and what we are getting here we can say it is output. So we can define here AND or NOT, NAND, NOR, XOR, and XNOR. Input, output, and the assign is the output that we want that. So we put here equal, and these input like for the AND, A and B, for the OR, A or B, for the NOT, complement A, for the NAND, and its complement for the NOR, and or its complement for the XOR. So it is the exclusive part, and XNOR, so it is NOR and it is exclusive. So this is how simply the Verilog coding and the software use. Hope so understand it, and Allah Hafiz.